Okay, so let's fill in this table together of the characteristics of both sine and cosine. The first thing I want you guys to notice is the differences between our sine and cosine and the similarities. Some similarities would be that they happen to be between 1 and -1 along our y-axis. Both graphs happen to occur between the two. The same type of similarities is that they have the same type of quadrantal angles that we're using for points to create these graphs. So those are some similarities that we're looking at. The other idea is that both of them have a period of 360 degrees, right? One full time around a circle from 0 degrees all the way around to 360. We've created a sine graph and a cosine graph that are functions going from 0 degrees to 360. That is one full period around our graph. So those are some similarities. A couple other things to look at is that our sine graph happens to have one max value and one min value, where our cosine values have two maximums and one minimum. The other difference is that our sine value starts at 0, 0, where our cosine graph starts at 0, 1. So a couple of things to keep in mind about those graphs so that when you see them pop up, you kind of know what you're looking at and what you're looking for. So let's fill in some of this information. We're going to go straight down along this sine, and then we'll move over to our cosine. So our parent function, again, our general forms of sine and cosine are given to you guys above. A and B are both constants that happen to be in front of both sine and cosine for A, and B is that number in front of x, and we'll talk a little bit about what that means in a little while. But our parent function is when both A and B are in fact 1. So these are our parent functions for both sine and cosine. So along the column for sine, we know what our general graph looks like. We know that goes through 0, 0. It's got one max and one min. So our domain from left to right, our domain again deals with our x values. And our x values, if we go left to right, these arrows keep going on and on, which means it's periodic, so it keeps repeating the same pattern, but the arrow is there to show us that it continues this pattern on and on. So since left is our negative x values and right is our positive x values, since they continually move on and on, we know that our domain is all reals. I don't know if you guys have seen that symbol before, but what it means is that my x values are all real numbers. It spans all real numbers, all negative values and all positive values. And again, my x is going off of the degree measurements here. So all positive and all negative degree values are part of our domain for our sine graph. Our range, we remember, deals with our y values, and our y values here are the sine values. It's our axis that runs vertically up and down. And in our parent function, we actually have restrictions because we don't have a graph that goes above 1 and we don't have the graph that goes below -1. So our range for y is not going to be all real numbers. It doesn't continually grow positively in the y direction and or negatively in the y direction, but it's actually between these two values. So our domain, or I'm sorry, our range is y is going to be greater than -1 or equal to -1 or less than or equal to 1. So our range happens when y is either equal to or between -1 and +1. And this again is for our parent function. From the start of our graph here to the end of our graph, we have one full period, which we know to be 360 degrees. That's one full time around our unit circle, where we have a maximum value, a maximum sine value, which means our biggest sine value, at +1, and this happens at 90 degrees. And we have a minimum sine value at -1, which is our smallest number for a sine that we possibly have, and this happens to be at 270 degrees. If we switch over to cosine really quick, some similarities are going to pop up in this table. Again, in this graph it looks a little bit different than our sine. We're starting at 0 degrees and 1, so we actually have two maximums here and one minimum. So our domain, since our graph continues negatively infinitely and positively infinitely, we know that our domain spans all x degree values. So our domain for cosine, again, is all reals. Just like our sine, our cosine happens to be a graph in between two values, which happens to be 1 and -1. So our range for cosine, again, is values equal to or between -1 and +1. One full time around our circle gives us this graph. So from start to finish, from 0 degrees to 360 degrees, we get this graph right here. So the period of this graph is also 360 degrees. We also know this to be 2 pi for both of them if we talk radians. So all of these degrees can be changed to radian values as well, but we're going to stick with degrees since they're a little bit easier to get the concept down. A little bit different is I have 2 max values instead of 1. My sine value only had 1 maximum. My cosine values actually have 2. My maximum, though, for both of them happens to also be 1. This happens at 0 degrees and 360 degrees. If you remember again, 0 degrees and 360 degrees are coterminal. I have 1 minimum for cosine, just like my sine values, and that happens at -1. And that happens at 180 degrees for my minimum value.